Welcome to Zebra Aurora Vision Studio. In this tutorial, we'll take a closer look at the Detect Points tool available in Zebra Aurora Deep Learning. We'll learn when to use this tool, how to work with it efficiently, as well as go through the process of points labeling, training our deep learning model, and testing its performance. The Locate Points, or LP in short, is one of the deep learning-based tools available in Zebra Aurora Deep Learning add-on. It is used to precisely locate and classify key points, characteristic parts, and small objects within an image. Locate points can be used in a large variety of scenarios, for example in object counting, object classification, or obtaining coordinates of key points. The training phase requires the user to mark points of appropriate classes on the training images. The tool does, however, support automatic training features available in Zebra Aurora Deep Learning, which can greatly speed up this task. The Locate Points tool finds its use in many different applications, especially those where object counting or obtaining exact point coordinates is needed. Let's take a quick look at some sample projects using Locate Points to perform one of the main tasks. I hope our short introduction gave you some idea about how Locate Point works and in what kind of machine vision applications it can be used. In the following parts of this tutorial, we'll focus on building a sample program utilizing this deep learning tool. We'll also build a sample HMI interface displaying the images with results along with some additional data. We'll start from building the main structure of our program, namely from adding the deep learning and acquisition filters. We'll be using one of the example image datasets that come with Aurora Vision Studio. It's called Piece Location and can be found within the film strip control. Let's browse these images quickly. Now, let's add the deep learning filters, deploy and locate points, and create all the required connections between them. If you want to know more about model deployment, please check our technical documentation or watch the previous Detect Features tutorial where it is explained in detail. Okay, we've got all the filters in place. Let's make the connections now. Similarly to other deep learning tools, we need to specify a target directory for our model by editing the in-model directory output of the DL deploy filter. I'll copy-paste the target path, but you can choose any location you want. Okay. Everything's set now. Let's jump to the editor and train our model. Training a model for locate points is very similar to Detect Features. We add the images, label the points, set parameters and regions of interest, and that's basically it. If you want to have this process explained in detail, please check our Detect Features tutorial. For our training, we'll use only 2 images. This actually shows how powerful and useful the augmentations are when working with a limited number of image samples. Let's add these images to the training set now. Before we start labeling our points, we want to change the default class name first. This is particularly useful when working on a model that recognizes a couple of different feature classes. We'll be using a single class here, but it's quite easy to think of an example where our model would have to locate different object types like fruit, candy, or some metal parts. Let's click the cogwheel next to Object Class 1 to open the Class Settings menu and change the class name and color. It looks good now. Let's proceed to marking the points in the images. When adding and removing points, we'll be using two tools, Shape and Eraser. Moreover, we will be tweaking the feature size parameter, which sets the size of a circle region drawn around all marked points. Let's add a few points to see how it works. As we can see, each click adds a point and a corresponding circle around it. The optimal size is when the feature can fit within the circle along with some extra pixels. This gives the neural network some extra context to work with and usually produces better results. Let's zoom in and check how does the feature size work. Another parameter related to the feature size is downsampling, which reduces training image resolution. This can often improve model size and speed without any negative impact on the results. As for the feature size, the higher the downsampling level, the bigger the region corresponding to the selected feature size. Let's turn pre-processing on to see how downsampling works and how it correlates to the feature size. As we can see, reducing the downsampling level decreases the feature region. Thus, if we plan to use full resolution images, we might need to tweak the feature size a bit. Okay, let's revert to our previous settings and continue. Apart from manually marking all the points, which in our case would take a lot of time and effort, we can use some of the extra features to import the points or mark them automatically. While auto-labeling is not covered in this tutorial and will be explained in detail in a separate video, we can show you how to use the import feature to import a set of images and points marked and saved by someone else. Let's clear the training images set first. Now, let's click the import icon and choose the Import from a CSV file option. The second option allows us to import the points from a cloud-based image annotation service called Zilin. We'll not, however, cover it in this tutorial. Let's import the training images set along with points coordinates now. There we go. As you can see, this saves us a lot of time. We can now proceed to setting training parameters and training our model. Okay, let's start tweaking the parameters. You probably remember that we already adjusted downsampling and feature size a bit. We also use pre-processing to preview what will the processed image look like. If we look at the circle regions around the bees, we can notice that they overlap a lot. In some cases, there are a couple of bees within one circle, which can have a negative impact on our training. Let's try reducing the feature size and see what it'll look like. Yeah, this definitely looks better. Let's keep it at 16. Okay, let's set up other parameters now. I will not be explaining them in detail. If you want to know more, please check our technical documentation or watch the Deep Learning Detect Features tutorial. You can also find all the parameter values in the Deep Learning Locate Points example. which is available in Zebra Aurora Vision Studio. We're almost done. Let's set the stopping conditions and start the training. Before we train the model, there's one more thing we need to take care of. Notice the red light indicator in the bottom left corner of the screen? It indicates that the deep learning service is stopped. Let's turn it on before the training. The indicator light is green now, so we're good to go. Let's start the training. We can also adjust the chart settings to show the whole training progress. Let's do it now. Our training will be complete soon. The window will close automatically. We can check the results now. Let's zoom in a bit to get a better view. As we can see, accuracy for all the points is more than 97%. Let's check the other image now. This looks really good, even though there is a bee missing here and there. Due to them being on top of one another in some places, it doesn't really affect this inspection. The bees move a lot, and the missing ones will be accounted for in following images. We're back to the main program window now. Let's check how our model performs on a set of test images. Okay, we've iterated our program, but there are no results. That's because I didn't pull any results output into the preview yet. Let's fix it now. Now it works correctly. We can see all the detected points. Here some bees were not detected too, but it's not a big deal. The original project used a video recording. If a bee was missing in one image, it would definitely appear in a second or two due to them moving so quickly. Let's try other images now. Everything looks good. Here, almost all the bees were detected. We can also display the point scores. Let's change the preview layout for that. There we go. As we can see, most points have a score above 90%. That's a really impressive result considering that we use only 2 images for training. As an additional feature, we will build a very simple user interface. To open the HMI Designer, simply click the HMI button on the toolbar. The designer opened in a new preview. We could keep it that way, but it will be easier if we close everything else and focus only on it. The gray resizable area is our HMI canvas. Let's resize it a bit. It looks better now. Now we can start adding the HMI controls. All the controls are available in the HMI Controls tab and are grouped into several categories. We'll use just a couple of them located in the Controls and Indicators sections. We'll need Label, Program Control Box, Text Box, as well as View to Debox controls. Let's add the View to Debox first. It'll act as our graphical preview window. Adding a control is as easy as adding a filter. We can either double-click or drag and drop, and then draw its shape. Controls can be moved within the canvas. We can also use the auto-alignment features to arrange them properly. We'll display something in the View to Debox control now. As you can see, There are a couple of control inputs on its left-hand side. They work in a similar fashion to regular filter inputs. In our case, we definitely want to provide the control with an image. Notice that there is an extra icon next to the OutImage output now, indicating that this data is being sent to the HMI. Let's iterate the program to check the result. It works as intended. The images are being shown in the HMI control. Let's show the point locations in the HMI as well. We can use one of the in-data inputs for that purpose. Next, we'll add some control buttons to our interface. They will allow us to run or iterate the program from the HMI level. We'll use the program control box for that. However, we cannot add it while the program is running. We have to stop it first to enable HMI editing. It works now. Let's add the control. Let's assume that our HMI should also display the total number of the bees. We can display string or compatible data types using the text box control. Let's add it now. It would be great if we had a suitable filter output to connect with it. Let's see if we can find something useful among the hidden property outputs. There it is. Outscores count should do the job. Let's try it out. As we can see, it works great. It would be good, however, to change the font size. We can do it in the Control Properties window. There are many more options there, and if you want to learn more about them, please check our technical documentation. Yep, it looks much better now. Last but not least, let's add a simple label to describe this number. We'll use the label control for that. The display text can be changed in the parameters. We'll change the font size too, and arrange everything a bit. This doesn't look bad, but if we were making a real HMI interface, we probably would like to improve the design and align all the elements a bit. Let's make some simple adjustments now. Remember that you can select multiple controls by holding the Control key and move them together as one group. It looks much better now. I think we can stop here and call it a day. I hope you enjoyed this tutorial. Thank you for watching and see you again soon. This concludes our tutorial. If you want to learn more, please take a look at our technical documentation available at Zebra Aurora Vision Developer Portal. You can find links to the sections of the documentation relevant to this tutorial in the video description below. Thank you for watching. For more information on Zebra Aurora Vision software products, visit us at aurora-vision.zebra.com.